Everyone, let's discuss today's Leetcode daily challenge. And the problem is combination sum 3. Uh, let's discuss the problem now. Find all combinations of k numbers that sum up to n such that the following conditions are true. So they are given two conditions here. And the first condition is only numbers 1 through 9 are used. Like we have to use only 1 to 9 numbers, and obviously we'll do that. And the second condition is each number is used at most once. Like in every list there should not be like more than one. There should not be any duplicate numbers like repeating one twice, like two twice or three twice. We should not do that. Return a list of all possible valid combinations. The list must not contain the same combination twice, and the combinations may return in any order. So we have to return all those valid combinations where there should not be any duplicate numbers in the same list, and we should return all those combinations in any order. Okay. Okay friends, before solving this problem, I strongly suggest you to solve like other two problems. There are combination sum 1, combination sum 2. Like it's a simple tracking approach. If you know the concept of those two problems, right, this problem is much easy. Like we'll add only one condition here so that we are able to solve the whole problem very simply. So I'll drop the problem links in the description. Please go and solve them first. So now let's discuss this problem. Now we'll discuss this by analyzing the code. So what I have done here is like I have initialized this is a function given vector int combination sum 3 int k int n. Here k is a size of the array and n will be the target sum what we have to find, what we have to like target sum of the numbers in the given form list. And see, let's see the first example here where k equal to 3 and n equal to 7. So the list size should be 3 and the target sum should be 7. If we add these three numbers, we'll get 7. So this is the only possible case. We don't get other possible case from here. And if we see the second example, k equal to 3 and n equal to 9, so the target sum should be 9 and the list size should be 3. So these are the valid lists. We are able to return 1 to 6. When we add it, we'll get sum to 9, and this thing 9, this thing 9. So we have to return these combinations. So and when k equal to 4, that is a 4 length list, and it should be added to 1. So there will be no possible subset which can form like this, right? So we should return the empty list. So let's discuss the code here once. So what I have done here is I have initialized the vector int final as a global variable, and I'm returning the global variable here. So at last we'll do that, and I'm initializing a vector int ans here, and I'm writing a function called check where I'm checking every number. So what the condition they are given, only numbers 1 to 9. So for every number from 1 to 9, I'm checking the given conditions and I'm generating all the possible subsets of the given number. So I'm checking from 1 here, and n is the target sum which is given in the problem itself, and ans, like I'm initializing this vector int ans, and k will be the size of the list what we should form. So let's see the function here. Int I, this will be 1 initially, and target will be the n what we got in the question, and I have taken the vector ans here, and int k, that is the size of the list what we must form. And in these three cases we just return, because whenever the target equal to 0, that means we got a list. Whenever target equal to 0 and k equal to 0, that means we got a list which is of size k, and the sum of numbers in the list equal to target. In that case, we push the answer vector into the final vector, because we got the list of size the k and sum up to the n, and we push that into the final vector and we'll return here. And whenever we get target less than 0 or k less than 0, because in that case we have nothing to do with that case, right? So we just return it. And whenever I equal to 10, that is in the problem statement, there's see here only numbers 1 through 9 are used. So whenever we get whenever I equal to 10 or more than 9, we have to return. We don't need to consider the case, right? So we just return here. So these are the three cases we just return here, and the first case we push the answer into the final vector, where we get the length equal to k and sum up to n. And carefully check here, ignore the particular element. So we have many combinations, like we have to, like, there will be another set like 1 to 6. So there is the size of the list will be considered, and list like 1 to 6. See here, consider example of test case 1. Here k equal to 3, so the size of the list is 3, and when you add up all the elements, what you will get? 6, 7, 8, 9, 9. But 9 is not equal to 7, right? So we should ignore this. So we should ignore this list. So in order to do that, we just simply increment the number, the ith number, by 1, so that that particular case can be ignored. And if when we get the case called 1 2 4, where the size of the list is 3, and when we sum it up we get 7, so at that case we should include that in our main list called final vector. We should include the list in the final vector. So that's why we're pushing the element in ans, and we are moving to the next number, that is I plus 1, and we are reducing target minus 1. That is, whenever we include a particular number, we'll decrement the n by 1, n by the particular number, so that we have to check the remaining condition to get the particular list where it sum up to the given n. And we are returning, and we are reducing the count also by 1. And at last, whenever we get a, and this is the backtracking condition, where when we get the list of size k, and when we sum up the numbers of the list equal to the n, then we just pop back the last element, and which, like, we will pop back the last element, and we'll check the previous we go to the previous condition, and we'll check the all cases of those conditions, and we'll generate another list from that. So this is the condition of backtracking. And yeah, after this thing, like, every answer will be, every satisfied list of in considered in the answer will be storing into the final vector, and we just return the final vector here. We'll run the code here. Yeah, it is accepted. I'll submit. Yeah, thank you guys.